Hello, welcome back. So now we have resolved the technical issue with Excellency Kusal. So I would like to call Excellency Kusal to make a presentations. Excellency Kusal. Hello. Hello. It seems like he can hear us, but we cannot hear him. I would like to call the next presentations. It is from the two presentations from MRC. I would like to call Rattykone to start the presentations. Rattykone, are you there? Hello. Gone.
Can you hear me? Okay.
Okay. We got Rattykone.
Yes.
Dr. Winai. Gone, can you mute your microphone first? Yeah. So the next presentation is by Rattykone Sayasane on the modeling of the impact of the climate change and development of development infrastructure on the Mekong flow sediment regime and the water quality. Rattykone has more than 10-year experience in working in water resources sphere that relate to the data management, remote sensing, and GIS, the modeling river basin planning with the Lao government and the MRCIS. Rattykone has joined MRC Council study since 2016 as part of the modeling discipline team in the work of the model result assessment of MRC decision support framework. And he has extensive experience with the e-water model. Rattykone, without further ado, please start your presentations.
Yeah, thank you, Dr. Paradis. So, okay, I share my screen, but it's still not full screen. Okay, so thank you very much for inviting us to join the very special conference from the e-water source. My name is Rattykone Sayasane, representative from the Mekong River Commission Secretariat. So today I am going to present you the model result from the council study, or we call is the study on the sustainable management and development of the Mekong River, including the impact by the mainstream hydropower project. But we will focus on the part of the hydrologic and water resource assessment.
Gone. Can you share your full screen?
Yeah, I try to share the full screen, but let's stop maybe.
Do you want me to run from here?
Yeah, it will be okay. Bong, please details.
Yep. So I will share my screen. Yes, go on. Please continue.
Yeah. So next. Okay. So my presentation will include the brief introduction about the study, and will be in the detail on the modeling approach and the result from the study and the conclusion. Next. Bong, next please. Wait. So, could you go back one slide? Back. Okay. So the study, the councils. Oh, next. Next. So the council study start from the decision from the minister of the 4 member countries of the Lower Mekong Basin. So they agreed to conduct the study on December 2011, and this study spent time for almost 4.5 years for the preparation step to develop the concept note, and also to prepare the data and discuss with the member countries. And then the rest 2.5 years is to implement. So the study end on December 2017. Yeah. Next. Next please. Yeah. So in the council study, we conduct the comprehensive cumulative impact assessment, which include the 6 thematic we have in this PowerPoint. So the main sector we include in the study is the irrigation, hydropower, control and navigation, and agriculture and land use, and also the domestic industrial. So the study will assess for the 3 dimensions on the hydrological, social and economic and environment. So the hydrological part from the hydrological part assessment is considered as the discipline analysis. So we will focus on the hydrology, sediment, bioresource, economic, and social. So from the graph, you can see that the presentation will focus on the hydrological as the fundamental input for the other assessment. Like we have the hydrological models to provide the input data for the water resource development sector, and also to feed into the other tool for the environmental analysis for biola, and also for the social and economic term. So next please. Next. And about the modeling approach, so this study we use the most of the data that we have in the Secretariat, and also the data provided from the member countries. We have our monitoring station data for both the water quantity and qualities, and also the data from the member countries, including the national development plans, and we also use the data from the global source, like the satellite data, and also the some parts of the information from research papers. And you can see here that a part of the information, we also get some climate change model from the SimKim models, and also the development plan for the next future. Yeah, please, next. Yeah. And for the tools that used in the study, the left-hand side is the full tool that we use here for conduct the sediment for hydrological and environmental, social, and economic. So we have a list of various of the tools used. For example, here we have the DSF, our decision support framework from the MRC, and also we have the tool for BioRAS for environmental assessment and the Murphy for the socio-economic. And looking into the detail for the hydrological assessment part, we have the tool for conduct the hydrological assessment is a SWOT model, is the soil and water assessment tool to provide the sediment yield and the water yield. And also from the hydrological model, for SWOT model, we connect the tool to the water balance called is the IQQM models to process the water use extraction in the basin. And in terms of the water quality assessment, we have the e-water source model as a supplement tool for the study to help us to conduct the sediment and nutrient trapping in the reservoir. And after we got the all of the results from IQKM and e-water source, we feed it to our MRCIS model, hydrodynamic model, to produce the sediment, to produce the flood mapping and the change in the sediment. And I would like to emphasize here from the foresight here, the IQKM model and e-water source model will be used for the tributary and the dam in the China Pass to conduct the sediment tapping in the reservoir by using the Bloom equation. And for the mainstream dams, the country agreed to use the hydrodynamic model MRCIS to conduct for the sediment passings. Yeah, please next. So for the e-water source modeling approach, we divide into two parts. One is for the water quantity. And for the water quantity, we apply the same approach with our existing water balance model. We use the river network routing in the river system and consider the water use from other sectors. And so in this study, we the e-water source used to duplicate the IQK model for the flow, and by using the plugin for convert from IQK from the existing IQK model to be the part of the e-water source. But top up from the water quantity, the e-water source, we apply the concept of the Bloom equation that I mentioned earlier. So we have the graph to compare and check with our available sediment data from our program. And with and in terms of the nutrient, we did the assessment for the total nitrogen and phosphorus. So we apply the e-water source introduced to apply the ratio of the nutrient extract to the sediment in terms of the percentage. So we have the two data sources to verify our results. So one is we use the analysis of the change in the sediment inload at the Chiang San. Chiang San is the most upper station of the lower Mekong next to the China Pass. So we use this station to verify the result for total phosphorus and nitrogen. in the periods of the 2010 and to 2015 with the two largest dams of the China had been conducted, and also verify with the data from our chemical analysis in the environmental database of our tool. So the next. So for the study, we have defined the scenario. So we conduct the baseline, the existing baseline in the condition of the year 2017, in the year 2017 at the yearly development, and then we have the three main scenario in the year 2020 and the year 2040. So in the year 2040, we have two kinds. One is with the climate change impact, and the other is without the climate change impact. So the development will consider on the six main sectors, mostly in the hydropower, irrigation, agriculture, development, and industrial, and flood protection and navigation. So a part of the main scenario, we have developed also the sub-scenario to make more detailed assessment for the sector level. So we based on our development in the year 2040 with the climate change impact, and we make more for sector in the hydropower, irrigation, agriculture, land use change, and flood and infrastructure, and also the climate change itself. So the total sub scenario is 12 sub scenario. Next, please. So here is the result from the study. So for the flow assessment, we see no significant change on the annual flow, but for the seasonal flow, we see the significant change clearly. For example, in the dry season, the flow will be increased for all key stations along the Mekong Basin, and it will the flow will be decreased in the wet season, also for the on station. Yeah, next, please. And in the data, in the Mekong Delta, so when looking at the impact on the flood prone area, so we can see the impact on the chain. Here we can see that the flood area will be increased both in the year development 2040 and 2040, and some slightly change for the climate change impact for both three scenarios. Yeah. And also it will impact on the salinity institution in the delta. So we can see more salinity area in the next development years. Yeah. Next bit. For the sediment result, this is a result from e-water source tool. So we can see clearly the impact from the development in the year 2020 and 2040. So at the graph, it can in the year 2017 we can see amount of the sediment around 140 million tons per year went fast to the data, but after the development 2020, only 47 million tons went back to the delta. So mostly 60 million tons were tapped in the main in the dam of the China Pass, and also along the tributary area from Mekong countries. And the most obvious case is like in the year 2040, also without or with the climate change impact, the sediment will be remain only 5 million tons per year, very less. So next, please. And here is the result for the nutrient assessment. So with the approach using the ratio of the sediment attached to the sediment, so we can see the 10 is similar to the sediment assessment. So among of the nutrient was tapped in the hydropower reservoir, and only few amount will be flugged to the delta areas. So next please. And here is the sum of the result for the sub-scenario in terms of the climate change and hydropower. So in terms of the climate change impact analysis for flow, we can see some different, or slightly different in the N1 flow change. Let's say it's around 10%, but in the seasonal, the change will be various based on the different scenario of the climate change. And for the sediment assessment, is the climate change is not impact much on the sediment and nutrient. So it's a similar case with the development 2040. And for the hydropower, this can see clearly on the flow is have no impact on the overall annual flow, only in terms of the season flow, like I mentioned before. But for the sediment tapping, we can see clearly that the flow is the key, play the very key important role on the sediment tapping for the Mekong Basin. You can see. Next please. And also for irrigation and land use change, two of these sub-scenario have very slightly impact on the flow and also the sediment and nutrient change. Next please. So we can conclude that the methodology for the Mekong for modeling approach is to use the accepted decision support framework tools and models together with the e-water source and the other models that familiar with the member countries in the Mekong Basin, especially for Laos and Cambodia. We familiar with the e-water source tool, and the e-water source tool play very important roles for the assessment, the sediment and nutrient trapping in the hydropower project, especially in the territory where our DSF models still have some gap or still not yet set up the model at that area. So in the overall, the annual flow will be slightly affected by development 2040, 20 and 40. Only the seasonal change will be found by increase in the dry season flow and decrease in the wet season flow, and also will be effect on the flood peaks and flood area in the delta. And it's clear that the hydropower development is play very important role and impact on the sediment flux. With the Sayana Dam in the year, with the full development in the year 2040, can tap the sediment up to 84% of the sediment that down to the Chiang Sand in the start point of our lower Mekong Basin. And if in case of the full development in the year 2040, the sediment risk to the delta will be reduced by 96%. And we found that the mitigation measure will help to reduce the impact. And similar case to the sediment impact, the nitrogen and phosphorus will be reduced by 63% and 70% accordingly. And the climate change provide less impact on the annual flow, but highly impact on the seasonal change that vary in different areas along the Mekong Basin. So we can say that e-water source had very similar concept with the IQKM model that used by the MRCIS, and member countries, but it provide more advantage on the water quality module. So it helped us to fill the gap in the past in the study. So the further application of the e-water source on the MRCIS work is being considered as the part of the reinvigoration concept. So my colleagues will present in the next slide. Yeah, that's all for my presentation. Thank you.
Thank you very much, Ron. There is one question that is a very general question. It's about data scarcity, data shortage in doing the modeling. Can you share with us what is your experience in the Mekong region? How do you overcome the data shortage for the modeling?
Yeah, thank you for the question. So the data scarcity is the issue not only for the member, not only for the MRCIS, but I believe that it's the problem for all organizations around the world. So some part of the study we try to fill the gap and overcome the data scarcity by request more data from the member countries, and also try to use the global source, the reliable global data source, and also we look at the resources, information from the resources that are public available in the internet. Yeah.
Thank you. Next, I would like to invite Dr. Winai, also from MRC, to give presentations on the reinvigorations of the data and information, reinvigoration of MRC data, information, modeling, forecasting, and communication platform. Sorry. Okay, Dr. Winai Wangpimool is a Thai national, Thai nationality. He is currently is the director of the technical support divisions, and he take a look at the river monitoring databases, information system of the MRC, decision support system, modeling tool, flood and drought forecasting, and he also supervised the joint study and research with the member country and also China. He has overseen the operation and planning and implementation of MRC procedures that related to the data sharing, maintenance of the flow on the mainstream, and water use monitoring in the lower Mekong Basin. He also oversight the operation of the MRC Regional Flood and Drought Management Center in Phnom Penh. Dr. Winai, the floor is yours.
Thank you, Pallavi, for your short introduce. Could you please share screen for me? Pallavi? Dr. Pallavi? Okay, thank you. For this presentation, I would like to present you about the reinvigoration of data information system for the MRC. My presentation has three parts, but I will provide you in short and briefly because we behind schedule a little bit. Next, please. Yes, the first one I would like to introduce about our organizations. Next. Yeah, as you know, this is the left-hand side. Is you can see the Mekong River is originate from the China, come to the Dao Siem and the Mekong Delta in Vietnam. For the MRC, we have the 4 member countries, including the Cambodia, Laos, Thailand, Vietnam, and also the you will know we have the Mekong Agreement in 1995. Next, please. Next. Yes, this is our office. It's head office located in Vientiane, the capital in Laos, PDR. And also we have the Regional Flood and Drought Management Center is located in Cambodia, in Phnom Penh. This is center to support on the flood and drought forecasting activities. Under the Mekong Agreement, we have the 5 procedure to assist for the implementation of the Mekong Agreement. One of them is we have the procedure for data information exchange and sharing, or we call the PDIES. Under this one, this Secretariat, MRCIS Secretariat had been developed the Mekong information system in order to support the member countries. Next, please. The second one, I would like to present you about the current status on the information system. As you see on the screen, as we have the agreement, and then we have the procedure in order to the implementation on the information system. You can see we have the monitoring stations from the field in order to collect the data, not only for the water quantities, also that we collect the data from the water quality in terms of the monitorings. And then all data are sent to our information system in order to support the many activities, like for example, for the study or the assessment by the applied modeling tools that my colleague just presented on the modeling applications, like that we have the DSF or the decision support framework, including the hydrological model, water balance, and also hydrodynamic, with supplement some additional tool like the e-source. We use support for our work, and also the many tools we use for the support on the part of the water qualities. And also the right hand side, we concerning on the capacity building for the member country, and also the strengthen the cooperation with the partner. Next, please. This should show you again about the current architecture of the data information system, or the MRCIS. The first column, you can see the data source. We have the many source from the data come to our server in the second column. But in fact, we classify into the 4 groups. The first one about the time series server, the second one about the spatial server, and the third one about the documents, and also the last one about the server load or the sector load, the database. And then we provide the information through our website or the web service, or we call the web portal, in order to provide many people to access into our system, like mainly we serve for the member countries, and also the academic, university, and also the end user and stakeholder. Next, please. This is show you about our product and service. Like we have the data from the collection from the field. We have the support from the member country in order to operation and maintenance the station, in order to secure our data to our system, and then we make available in the website, and also the data support for our center in the Phnom Penh, in order to provide the flood forecasting. Not only the monitor, we provide the assessment information, and also the forecasting in terms of water level, and also rainfall, both of time series and also the spatial over the basins. Next, please. This is our web portal in terms of the data service to the people, or to the public. You can visit our website in our link I show on screen. Next, please. The last one I would like to highlight on this one, because this is exercise, as you know, now is in the Mekong Basin have been development very fast in order to support the informations and the data to the member country to monitor and assessment what have been changed in the Mekong Basins, in order to quick respond in the timely manner. The exercise was designed by our CEO, Dr. Anpit Hadda, and also the Australia had been invited to work closely with us in order to assessment our current situation and also that provide further development by recommend using the design concept note for the MRCIS in order to the implement in the futures. Next. And then the MRCIS core team had established led by our CEO and also me from the technical divisions. The first draft had been developed with the Australian team, and then we used the first draft for the discuss among our team and get more the comment and revise into the second draft, and after that we use the second draft for the national consultation to get more the comment and suggestion from the member country. And after that, we revise again and bring to the regional level through the expert group for the data information and forecasting group. Not only the expert from the member, but including the expert from the Australia, from the China, from the Korean and US to join in that time. And then the final version had been submitted to the joint committee for the endorsement the document. This is our process to develop the design concept note on the reinvigoration of the information system. As you see on the screen, this is the product from this exercise on the design concept note. We have the two volumes or the two parts. First part about the current status on the technical review, what we have done so far, and the existing, we can see the weak points, see the strength point, and we need to looking forward to improve or enhance that system. And the second part is very important because we will see the trend or direction in order to improve in the next 5 or 10 years with the high technology and also with the support from the expert from the Australia. This will show you some photo during we have discussed in the expert group meeting in November last year. Next, please. This is summarized from the direction for the future structure of the MRCIS information system under the reinvigorations. In fact, we have the 4 components. You can see the number 1 is the first part, very important on the data input. In order to secure, talking about the data and sharing, this is we have the procedure on the data information sharing and exchange, and also that we have the many tools to support in order to get the data to our system. For the second component on the data management and also the data analysis and assessment, including the tools, impact analysis tool, in order to provide the result or the information on the assessment. And the fourth one or the last one is this output, or we need to release the output or the information to the practice. This part we need to enhance or improve our communication platform in order to quick respond and convey the message directly to the end user, especially for the Mekong countries member. The next one. This is again after we have the design concept note endorsed by the joint committees, and also MRC we have the new BDS or the Basin Development Plan, and also the strategic plan for the 21 until the 25. And the activity and tasks under the design concept note have been identified aligned with the MRC strategic plan, and also that we include in our multi-year work plan already, because now we just have the approved by the MRC Council member or the minister level to approve about our annual work plan, and the activity and tasks already designed And the major activity under the MWP or the multi-year work plan consists of 4 parts. The first about the collection and the acquisition of the data informations. And the second one about the data informations for the management. And the third part about the analysis and assessment. That's part of the modeling and tools. And the first one about the reporting and the communications. This is a main or the major activity, but we have the many tasks under the activity aligned with the strategic plan. Next, please. Again, we would like to thank you to all who have been to contribute and input to the concept note until we have the successfully and completed. Because without your from the expert from the e-water source and also we would like to thank you to Australian government financial contribution to this project through the Department of Foreign Affairs and Trade to make it happen. And also I would like to say again, would like to thank you to the Dr. Robert Carr, Dr. Paradis and Dr. Jeff from the e-water to their contributes very useful information until our concept note complete, and then we can apply or identify into our work plan for implement and ready for implement in next year. Thank you very much.
Thank you. Thank you, Dr. Winai, for very comprehensive presentation on the flagship project in MRC. There are a few questions for you. You show us about the data portal. Is that the data available in that portal and in MRC databases? Is it only for the MRC member countries, or is it available for all of to the other stakeholders outside of
Yeah, for the data we provide on our portal, we classify the user, but in fact we provide to all. But we provide for the member country, right, the internal user, because there is we call the primary custodians who provide the information from the member country directly to our system. They can access all unlimited. But for the external user, like the university or the end user, general user, they can access the available data on our website. But if they need the specific data, some specific data, we have maybe they pay for the service fee, like the handling cost, but not much for some kind of data. But mainly we have generate the information, very useful information, and try to make this like the interactive map. You can see the graph, hydrograph, and then you can export in the JPEG file or the image file. If you need the time series like in the table file, you can request to our system.
Thanks, Dr. Winai. Another question is about the data again. It's you guys collect data from various sources, and how do you harmonize those data for the modeling purpose?
Yeah, this is this very challenging task, because now we like I already mentioned, we classify the type of the data first. I focus on the time series, for example. Time series, we have the many parameter of the time series data, and then we're looking forward to use very the innovations or technology to help us to manage the time series data. This is the first part of the harmonize in terms of the time series. And also, if the data hides on the spatial, we have the geo server or the geo tools to manage the data in terms of the spatial. And also another one like the sectoral database like the satellite image, document. We try to classify first and then try to make it link it together by the using the communication platform. This is we looking forward to use the web-based system or the new technology or seeking the potential partner who they have the experience or knowledge on that, and maybe we will come for the technical support to the Secretariat or the MRC.
Thank you.
This is
thank you, Dr. Winai. There are a few more questions in our Q&A sessions, but since the time is very limited, I would like to encourage the questions should go to Dr. Winai and Rattykone offline or during the networking sessions that we have after this presentation. So I would like to, for this, I would like to call for the final presentation from Excellency Watt Botkosal. Excellency Kosal, are you still there?
Hello?
Yes.
Okay, now, sorry everyone for technical problem from computer or from Cambodia. So now I can connect. You hear me now? You hear me?
Yes, very well, Excellency.
Okay, very good. Thank you. Yeah.
So, do you want me to start your presentation or you do it yourself?
Please, you start my presentation. Yeah. Please start.
Yep. Okay. Please allow me to share the screen.
Yeah. Thank you very much. Good afternoon from Cambodia, and maybe
afternoon. I can start with your introductions. Excellency.
Yes.
So, Excellency, Mr. Watt Botkosal is the Deputy Secretary General of the Cambodia National Mekong Committee, CNMC. He has more than 20 years of experience within the national and transboundary river basin management and river basin governance. He has involved in multi-sector basin level development planning under the framework of the Mekong River Commission's Cambodia Water Partnership and the Global Water Partnership for Southeast Asia. Excellency Kosal, the floor is yours.
Thank you very much, Dr. Paradis, and good afternoon, everybody. As I said, that we very sorry that technical problem from my side. So now, thank you very much, Ivora, for invitation to me to have the opportunity to provide the presentation on the development of national DSS and integrated water resource planning in Cambodia. You may be aware that we have the national project funded by the World Bank. So we have under the MRC framework for IWRM project since 2012, and Cambodia, the last one we have in the Mekong IWRM project phase 3 Cambodia. So we start since 2016, and the project to be ended 2021, but because of COVID, possible to extend a bit for 12 months. Maybe we finish 2022. So this is the Cambodian project that covers two components for fishery management and for water resource management in the northeastern part of Cambodia. So you may know that important area, transboundary area on Sekong with Laos and Sesame with Vietnam, transboundary river basin, and in Cambodian side we call 4P that represent the river in Cambodian. Yeah, so this project cover 4 provinces in Cambodia, Rattykone, Mekong, Stung Treng, and Crotches. And the scope of the project, the scope of the project to improve the hydro made system in Cambodia. And the second development of the decision support the system, you may see the important role of decision support system to support the integrated river basin planning. And number 3, integrated water resource management and development in this area. And number 4, strengthening CNMC and MORAM organization, including the transboundary dialogue with Vietnam and Laos PDR that share river basin. Next, please. And the project produced really important, as you can see in the slide, important to improve the CNMC information system that exists under MRC support, that every country has the information system in the National Mekong Committees, and the project will support how to improve this system and with the DSS, what the connect to DSS, and we can use interface with this structure of the CNMC information system. So we will look back on the existing data and information in the system and require for the new data information or required by the DSS tool. So we will enhance this. And this link to the important how to improve the hydromet system in the area for P and 3S. So we will install the hydromet system like transboundary at the border in the Mekong with Laos and in the Vietnam, Sayasane and Saipo, and then improve the existing data that we have, and then we have new collection of the data from the new hydromet station. And the right side, that architecture of the DSS, you know, this is the new tool that developed under this project, really important, how the DSS will use to support the planning process, especially for the 3S and 4P. So we know the interface, the DSS will be supported by important e-water source and also HECRAS, and to support the water resource management, because e-water is water model, water resource management model, and HECRAS to support such flood control and flood management in this area. So the architect structure, DSS will improve the information system exists, like I said, exists in the CNMCIS, and also to develop the analytical framework to support the DSS tool, and also management tool. Yeah, and under database framework, we have the hydromet DSS data and knowledge, and also the planning tool, planning data. Next, please. This is the result from the model. From the morning, we talked about model. So the model is useful for the water resource management and development. And the model run from the different input and output. That input we put in the model, and then the output, the achievement, that what we look for the change. I can bring in important of the calibration of the model that we simulated, the model based on the data. We have baseline data and the scenario data, what we think about the next 40 years or next 50 years. So you can see we have a station in the river basin of the 4P and 3A. We can bring in one station. So the model calculated, compare to the simulated and calibrated, it look very fit, very good, you know, very good result from the model. Example, the rainfall for the Winai gouge, gouge. So we see that this model fit to the calibration and to the simulation of the model. So we do support that useful e-source model to support the DSS system. It is about the assessment methodology in the DSS, what we developed the DSS. So we have 6 scenario, development scenario, looking at the first baseline that we have since 1985 up to 2017. So they are including irrigation and domestic and industry water use, hydropower and water use, and combination of number 2, number 3, and also climate change is really important. And then the scenario number 6 we put in all. So this is supported by the e-source model that we can see that like from World Bank said, the process for scenario development is similar to the same what we think about what new change in the future if we require the water resources for like domestic, for irrigation or for hydropower based on the planning requirement. So we will see how they change in the rainfall or water flow in the river, and this compared to the investment, example, investment in hydropower or investment in water supply, investment in irrigation expansion, example. So the model is very useful to compare the requirement for the planning, and the requirement for the planning is also should be based on the vision and strategy of different sectors, especially based on 3 triple: social, economic, and environment in the country. And this model very much like a multiple purpose of the model. That means important to support the criteria, cost and benefit analysis, and then between what try to balance the economic and finance and environment. Next, please. So this is the result from the DSS tool that we have 6 parallel components. The first about the scenario, as I said, that development scenario based on the new strategy or planning from the government to investment in the area. So this is the scenario best to be used to support the investment plan in this area. And the scenario result will show us what happened if we increase the irrigation or we develop new dam in the rivers basin or in any development of reservoir. So how much the water will require and how much water will store, and then we will see what the impact downstream and upstream to downstream. And the multi-criteria analysis MCA is really important to do balance between economic and environment and social, how to look for the future development, and assessment depend on the sector require the water for their own development. And the CBA is really important, cost and benefit analysis. When we have the investment, we have to balance the cost and benefit, what the project costly to the environment or to social, and what benefit for economic or for environment itself. Yeah. And then the report important from the DSA, important for the decision-making process. So we will report to decision makers on their decision. Yeah. Next, please. So it is example for the area that we will develop the project. So we have indicator in IWM. Indicator, it means that what the scope of development can show acceptable indicator. Example for hydrology, how much water, how much flow when we develop any kind of the investment or infrastructure in this area. So the sub-basin level indicator show us possible available of water when we develop any kind of infrastructure or investment plan there. So link indicator where the acceptable indicator or not. So this is should be indicator accepted by the agency or by the government or by the natural resource condition regarding to the water issue, the water flow, water availability. Next, please. Can you go next? Yes, this is really important when we see the DSS in the river basin planning. As I said, that the DSS supported by the ESOS model and also HECRAS model to support the flood monitoring or management. So you can see the process for the basin development planning supported by the DSS. So we start with the scenario option, that the option provided by the scenario, the result. So example, there are internal and external scenario. The internal scenario is mean all resources available to support the sector development. Example like water supply, irrigation, scheme or hydropower development. So we will see the available water availability and so. And then external scenario can be the climate change.
With HDF.
Can be the climate change, and that population grow and require for the development, as the country strategy. So this DSS depend on the model, like important model, like I said that the ESOS model really important, how the input and output of model will support the basin development. So we call basin planning modeling. So the model based on hydrological model and calculated model. And then the model will provide us the result, and the result must be compared to the indicators. What indicator we need to development by environmental indicator, by economic indicator, by social indicator, in order to have the sustainable development or management in these basin areas. So and then the output to be adjusted to be reliable with the result from the MCA. The MCA, what we weight the score agreed by different stakeholders, especially the line agency, even the local community or other stakeholders in the basin. And then we can define the basin score, what we try to develop any kind of investment. And then based on that, we go with the basin plan. The basin plan will be based on different sector opinion and strategy. What we try to discuss based on this model of the DSS result, and then we start to discuss, to negotiate with the different sector for the investment of the sector. So this is the important DSS to support the river basin planning based on the result from the model analysis and model results. Next, please. So I would say that the DSS development to support integrated water resource management and planning in this area. We understand clearly about why the IWM. The IWM important to bring different perspective of development from different sector, perspective of the people, of the stakeholders, and the perspective from the basin development, like regional or transboundary basin management, different countries. So the IWM will bring the rank for water development scenario as we formulated in the model, like I said already. So the scenario would be assessed by various models, as I said already, in the basin, even the different basin, and how the DSF will give us how to maximize the benefit and minimize the cost, and also provide water-related security in this basin. The IWM best planning also provide the water resource assessment in the river basin profile. So we will see different sector development by using the DSS in this river basin. And then the priorities sector what based on the different opinion from the stakeholders. Yeah. So the IWM planning also to support how to develop the better planning in the area. The planning provide good opportunity or challenges, how the challenges to be addressed based on the result of the model. We can see the risk or uncertainty. Example, the water risk that not enough water, or the change in climate because of the rainfall change, because of the temperature maybe more like hotter. Yeah. And this planning also will provide us the good roadmap of the planning. So how to balance the zero sustainable outcome from the basin development plan. And the DSS based integrated water resource planning also provide us opportunity to work with the
University mentions the name Watt Botkosal.
The transborn area between Vietnam and Cambodia, and possible to support the river basin organization in the future in the country and in the transborn region. Next, please. Yes, I think that is my last presentation. So the project funded by World Bank to support capacity of the line agency, capacity of the people involved in the project, and then build strong the system in the CNMC in the country, especially the system linked to the model and linked to the design support system. So the design support system is dealing with the information system that allow us to easy to work between different line agency, different expert people, and also different countries. Like in Laos PDR, they also have the system. DSS in Vietnam also has the same system. So the system will be supported by the model, and the model will be supported by Hydromet, the system, where we can share the data information on the hydroecology system, yeah, or hydrogeology system, yeah. So the DSF really important for water resource assessment in the Cambodia, and based on the river profile that project developed, and also the river basin that we designed based on this DSS system and the models. And DSS is very good that we will support for decision maker based on the system, based on the model, based on the DSS, yeah, DSS. And the DSS will build very strong the capacity of the government, especially with the dialogue with the transboundary cooperation, especially Cambodia and Vietnam, that we share the river basin, especially the understanding and analysis of the situation, what happened to the joint development on the joint management of the transboundary river basin. And this SF will build strong capacity of CNMC and line agency. As I can say, this is new scientific model that never established in Cambodia. So the DSF that developed by the DHI and also supported by e-source model will be very interesting, very useful for water resource management and river basin management in Cambodia. And we look forward how to apply this system in the country, in this river basin 3S and 4P, and also apply with the Vietnam and Laos PDR as the upstream country, and how the DSA can be help to find a good solution for the water resource in the transboundary aspect. So I would like to end my presentation with thank you very much for eWater for support technical and also World Bank to support technical work and also for finance. Yeah. Thank you very much for your kind attention.
Thank you very much, Excellency Watt Botkosal. We have one question for you. It is from Vanapon. You mentioned about the national DSS in Cambodia. And how do you manage to link this national DSS to the regional DSS of the MRC?
You know, the word DSS exists. MRC, they want to improve the DSF to be the DSS. The DSS, it means in more details for the DSA in Cambodia National DSS to support the basin development planning, but not to develop the basin planning, because we have to extend the DSF function. You know, DSF function, there are many things, but the DSF developed under the MRCIS project phase 3 is to support the river basin planning. The MRC DSF may be comprehensive one to support the regional one for the mainstream river, but can be connected, can be support each other when the MRC will support the national DSS that we having now. How the national DSS should be more comprehensive to water resource management, water resource protection, water resource conservation, or water resource use. Like this morning we talked about the Winai water allocation and so on. So I think that this national DSS would be linked very well to the MRC. Like I said, that the DSF we have the 6 components, start from the scenario and analysis, and at the end to the basin planning. So everything are related with the MRC. Like you can see the design of the CNMC IS and CNMC DSS. So you can see all like interlinks or interlink between those model and between the tool. Yeah. So no problem that MRC and CNMC DSS not possible to work together. Yeah. I think that they are possible to work or to link or interface any model each others.
Thank you, Excellency. Thank you so much for your presentation and the question and answer. Now our sessions come to an end. As I would like to give a big applause to all of the speakers, and thank you very much for your contribution, and thank you very much for the participation from the different stakeholder in this forum. We have 40 and 60 participants in this, and now we would like to close these sessions, and we encourage you to go around the table to say hello, to shake hands. We cannot shake hands in person, but maybe say hello to old friend, colleague, and start your networking within the Mekong session, and also for the main conference sessions. In the main conference session, now they have the technical Q&A, so it is a good chance to ask the question to our software development team in the main session. But you also can remain in this session and talk to the people from the Mekong. We will have the closing session after the technical Q&A session in the main conference. So again, thank you very much for all the speakers in this Mekong session, and thank you very much for your participation, and we hope to see you again next year. Thank you.